Hello, Professor. It's Sissy.
It's Nathan.
Your two favorite students
In the
of
whole
all
wide
time.
world.
All right, so if you notice, the beginning of our code looks a little different. But that's because our program implements the collision detection using the separate axes theorem, which states that if you draw a line between two objects without intersection, then the two objects are not colliding. Our program contains a few new global variables that are not in the original program. The x and y variables are deleted in favor of a simple set of coordinates. In addition, we added a new position coordinate set which contains a hypothetical future position of the object that will be explained further in a bit. We also added a speed variable so we can easily change the speed of the character. Our main loop starts and opens the game window. When a key is pressed, our move function is called, and as parameters, we give the current position, speed, and key pressed.
So the move function is implemented up here. So it takes in a position, a speed, and a key. So inside of this move function, we have four separate if statements. So if the key is equal to pygame.left, right, up, and down, it will run the corresponding code here. So first we want to check that if it's going to move off of the screen, then we don't actually run any of the code in the following. So first we will check if the position of the x, which is the pose 0, is not equal to 0, then we can move and test for a movement. If it is equal to 0, that means that it's on the very left-hand side, therefore cannot move off of the screen. So same here with the right. If it's not equal to the very, very right-hand side of the screen, which is the grid size minus the square size, because the coordinate starts at the top left, so we have to minus that out, then we can continue with movement on the right, and same with the up and down, just with the y coordinate instead. So inside of these statements, so if it can move and it's not going to move off the bounds of the screen, then first we are going to set new position, which was our variable that we instantiated up here. We'll set new position equal to the current x position minus the speed and the current y position. So we do minus the speed in this case because we're turning left, so we want the x to go to the left. For the right, we'll do the same thing. We're just adding the speed, so it goes to the right. And then same for up and down. We'll just do that for the position 1, which is our y coordinates. So minus and positive for up and down. And then we will call isValidMove, and we'll pass in the new position. So isValidMove is stated right below. It takes in a new hypothetical position. What we do to test if a position is valid is we're going to loop through the entire game board, which is these nested for loops. And we'll take the grid position, grid j and I. If it's equal to 1, we know that that position contains a barrier. If it's equal to 0, then it does not contain a barrier. So if the position is equal to 1, then we want to test that it will not result in an overlap if the new position is changed for the player. So what we do is we set the position of the barrier equal to the x and y multiplied by the square size. So this just indicates the location of the barrier. And here, if is overlapping, and in the is overlapping method below, it accepts two coordinates, x and y for the player and x and y for the barrier. So let's explain that here. So it just accepts two coordinates. So given the position of the player and the barrier, this function will determine if the two squares are overlapping. The method used is called the separating axis theorem. So the way we implement that and test if there's a line in between the two without intersection is we first define two center coordinates. So we do this by setting the x and y equal to the player center, and we offset it by exactly half of the square size on each, the x and the y. So this will result in the player center and the barrier center being located directly in the center of the object as opposed to the top left-hand side, as the other coordinates are. Then after we determine the player center and the barrier center, then we can determine the distance x and y. So we'll take the absolute value on both the x and the y of the player X minus the barrier X, and then the player Y minus the barrier Y. We take the absolute value because we just want to know the absolute distance between the two objects. We don't really care for negatives. So once we obtain these two values, then we can verify if the X and the Y both have the distance between the two to draw a line without intersection. So we do this by testing the X position. If it's greater or equal to the square size, then we know that we can draw a line in between the two. If the Y position is greater or equal to the square size, then we know we can draw a line between the two. If it's less than, then we know that there's some sort of intersection because the objects are closer than they physically could be by just moving them together and touching. So if they're any closer, then we'll return true. Otherwise, we just return false, indicating that there's no overlap. So this will determine if there's actually an overlap on two positions, and we'll call that overlap on every single position that contains a barrier in our isValidMove statement. And this loops through the entire game board. So this covers our bases. There are probably more efficient ways to do this. You might not have to loop through the entire board, but we're doing that and it works pretty fine. So we'll go ahead and show you the program working now.
Alright, so as you see, this cute little pink cube is going to move right into this barrier, and I'm pressing right, and it's not going to move. I'm going to go down, and it's hit another barrier, and it's not going down further. We'll go left, and we'll actually go right. So, as you see, we have accomplished the goal of the assignment.
We can test it on another board. You can see it can't go below the screen. And we can test it over here. All right. Thank you.
Thank you.
Bye.
Bye.